Now let's set up the exponential fit. So here is the data, and once again go to scatter plot, first one, and then we will format this and insert an exponential trend line. Okay, now we'll go and insert the exponential display equation. Now move the equation and format it. Trend line label, let's use 5 decimal places. Okay. That's the constant part A, and the exponent for E. And once again, let's go and clear the formats so it will appear properly. Okay, now so these are the coefficients for 3 different fits. So let's see how the prediction is going to be for our demand under these price conditions. So if it is linear, then you'll have intercept, make that absolute reference, plus slope, make that absolute reference, times that price. So that will give you the estimate based on linear demand function. Now if it is power, okay, look at how power works. A times x to the power of b. So A, that's our constant, make sure that that is absolute reference, times x is your price, to the power of b. So that is your power function forecast. So that gives you an estimate. And then the exponential, once again go to exponential function and see how the function is. It is A times E. E is a constant like pi. So E in Excel, you can get the value of E by using the function exp. So exp to the power of b times x. So that's our prediction. So it is A times exp to the power of b times the price x. So that will give us the prediction using exponential fit. Now I need to absolute reference A and absolute reference B, otherwise the copy won't work. Okay, here again I need to make sure that B23 is absolute referenced, and here I have the absolute references correctly done. So now copy that. Okay, make sure that we have it until the last one, so 12 months. So here these are the predictions. Now we want to compute MAPE, and let's look at what the MAPE formula is like, and then we will set up the formulas here. Here is the formula for absolute percent error. So this is given in page 49. So the observed demand minus the predicted demand. So this is your forecast error. You take the absolute value of the forecast error and divide by the observed demand, the actual value. So this expresses the forecast error as a proportion of the observed demand. So you can do this for each demand value, and then when you compute the average of all of this, you get mean absolute percentage error. So that's what is called MAPE. APE. So we need to set up APE for each demand and prediction and then compute the average. So let's do that in Excel. So we need to do absolute value of the actual demand minus the predicted demand. So actual demand. So now I'm going to do absolute referencing here so we can copy this formula to the different columns and different rows. So as you go down the rows, the demand should change as different rows changes. So C4 to C5 to C6. But when I copy across, the column reference should not change. It should be fixed at C. So we need to absolute reference the column C and not the row 4. Okay, minus the predicted demand. Okay, and this is to be absolute referenced, and then divide by the actual demand, and once again should be properly absolute reference like that. Now usually this is represented as a percentage, so let's change the format to a percent. Now if we copy that way and then copy down here, and then we do an average of this, that's our MAPE. So now copy that across. So these are the mean absolute percent error. So the smaller the value, the better the fit is. So between these three different models, power model is the one that gives us the least MAPE. So this has the best fit. So we'll use this best fit model in the next tab to do further analysis. We'll set up the model and we will do sensitivity analysis.